Okay, so today we are going to look on data visualization, and I'm sure you are familiar with the one visualization that is from Excel and all other softwares that we use in data analytics. And the first question is, what is data visualization? This is a graphical representation of information and data. So by using visual elements like charts and graphs, maps, and all other types of visuals that we use in statistics or in data visualizations. So data visualizations tools provide an accessible way to see and understand the trends, outliers, and patterns in data. And additionally, it provides an excellent way. It will provide an excellent way for employees or business owners to present data to non-technical audience without confusion. Now, we will have a view on some data visualizations, and apart from the ones that are documented in this presentation, we will look on other visuals that are present in STATA. That are present in STATA. So I shared the notes and the dataset that we are supposed to use today. The dataset is the ERIS dataset, and it's important you have a view on what is ERIS datasets, or the components that make up the ERIS datasets. And the first one, the first attribute, or a general history of ERIS datasets. These are datasets from flowers. These are datasets from flowers, and the dataset consists of the sepal length and sepal width, petal length and petal width of a flower. So these flowers, scientists or the researcher wanted to understand the characteristics of certain flower based on the species. So in this dataset, ERIS dataset, we have species. We have 3 species. That is flowers from Vascala species. The other one is Virginica, and the other species is Setosa. So that is basically what ERIS dataset consists of. So if you have any question, please feel free to ask. Yes, so yeah, that is it. Downloads. I'm sure to know you have the dataset with you, so we can now load the dataset in the STATA memory for visualizations. Yes. So the first one, we were starting with the histogram. We will start with histogram, bar chart, lines, scatter, box plotting, pie charts. Hizo zingine zote we will just have a look on each one of them. So yes. Mr. Joseph, how are you? Tumekumisi sana in this thing. So I don't know, wengine wananiambia hakuna power kwao. So tumekuanga watano. So let's just continue. What are part of the recording of the class later. So we load the dataset first, and you remember the syntax or the steps for loading datasets from Excel to the STATA memory. It's very simple. So you just click on File, click on Import, Excel spreadsheet, click OK, then browse the Excel file. Yes, so we are browsing it. So the dataset is the Iris dataset. We are using the Iris dataset. Then open it, and from that we import our first row as variable names. Then we click OK. So we click OK. You can see we have the dataset here. You can see we have the datasets. So we can just check what might be missing in our dataset. So this was just some typing errors. The column F, G, H, and J, we can drop them. They are of no use. So we just drop. You just type drop F and the command. So actually, what we are doing, we are dropping these columns. They carry nothing. So we can just drop them. The other one is drop G. The other one is drop H. The other one is drop I. Drop I. So from there we can have a view. We can have a look. Okay, so our data is now okay. So our data is okay. So this is the sepal length. We have sepal length of flower. We have the sepal wing. We have the petal length and petal wing. And the last column is the species of that particular flower, understand the paru. So yes. So from that now we can Frida, how are you?
I'm fine, thank you.
Umekuja late.
Yeah, I had some problem with my internet, sorry.
No problem. So, tujaendelea sana. I think you can catch up with us. Have you downloaded the notes and the dataset that we are going to use for visuals? Brenda?
Yes,
So, you have loaded the dataset in STATA memory, yes?
that's what I'm trying to do.
Okay. I nitangoja you when you are done, you tell me, then I proceed.
Okay.
Okay. Barasa, Bright, Bright, are you with us? Mr. Joseph.
Yes.
Are we together?
Yeah.
Okay, so
Just checking the notes.
okay. Frida, I'm waiting for you.
I'm done.
Thank you. So, okay, let's continue now. So these are the attributes of our data, or the columns of our data. So we have the sepal length, sepal width, petal length, petal width, and the species. So we are going to do some visualizations on specific columns, and from there you can apply the same concept in any other data, in any other data. So yes. So the first one is for histogram. The first visual was for histogram. So all of you understand what we mean by histogram. This is just a graphical representation of the distribution of data sets. So it will consist of series of rectangles, like you can see, and we call them bars. Then that are placed side by side on the horizontal axis. So the height of each bar representing frequency or count of point falling within a specific range or category. So the STATA command for histogram, for example, we can histogram either petal length or petal width. So you must have one specific variable to plot its bars, so that we can have an histogram. Yeah, so let's try to have the histogram here. So we are histogram of let's suppose we have that one, the sepal length, histogram of petal length. So you can just click OK and wait for your output. Are we together? Friends, you know how simple these things are. So just command histogram, then the variable that you want to have in that particular histogram that you want to produce. So and you can also do the same using the graphical user interface. Let's see how we can produce histograms using the GUI. you can just click on graphics, then click on histogram, then from there you can select the variable that you want. So you can select the variable that you want, and I want you to check here, check this one here. I think you understand what we mean by continuous data. By continuous data, okay, let's display this one here, and we display the other one from discrete so that you understand what you mean by continuous data. Continuous data, it means the end of one point will be considered as the starting for the next point, in your plot. Yeah, so it's the same concept, but suppose we repeat the same for the data that are discrete. Let's see what we will get. I think you can see what you are getting here. So this is point by point, so every point is included here. But now one may ask what is happening here. So the STATA will compress the bars to fit in the pop-out window. That's why the wind are different, and the starting so yes, that is how we produce a simple histogram using that software. And we can have the scatter. You understand that scatter plot is used to display the relationship between two words, between two variables. You must have a variable on x-axis and another one on y-axis. So yes, you must have one on x-axis and the other one on y-axis. So this is it. You can this two-way scatter plot of petal length and petal width. So the same command, you can produce it from this part here, graphics two-way scatter, and you have to click on create. Then from there you select from these bars, from this basic plot. What do you want? You do want the scatter, you do want the line plots, do you want the area bar spikes, all those things. So not for us, we want a scatter plot, and it's a basic plot, for example. So on y-axis, let's have sepal length. On y-axis, we have the sepal width. Then click exit and click OK, and click OK. What do you get? You just get the points, the scatter for sepal length and sepal width. So you can repeat the same for the petals. Let's see whether petals are correlated. So here we select petal length, and then X is petal width. Accept and click OK. That is our plot 2. I think you can see what is happening here. So basically you can have a conclusion on this. You can make a proper conclusion on this one. So the sepal length and this is for sepal length and the petal length. Yes, you can see here. So let's repeat for petal and petal length and petal width, so that you can see whether you can make any conclusion there. Petal length, petal width. Accept, click OK. Let's see. 2 scatter of inaccessible. No. We have to delete some things here. This one. You have to disable these ones, so that they may not be included in the next what? In our next plot. So this is petal length and the other one is petal width. So you just accept and click OK. Yes, that is it. So what conclusion can you make from petal length and petal width? These two variables are positively correlated. So increase in petal length increases the petal width. Yeah, that's why we have these points in one line. They lie on the same line. That's what you mean. So these points displayed on graphics in this manner tells that there is a very positive correlation between petal length and the petal width. And the petal width. Yes. We have the bars. We can have the bars. For example, graph bars of petal length of a species. I want we can access that one through this point here. You just click on graphs, bar charts, bar charts. From bar charts, we include the mean of it will not be here. Let's just use command for this one here. Let's use this command, graph bar comma of a species. Let's see. graph bar petal length. Over species. Let's see. So that is it. So we have this STATA, and what we have is the mean of petal length. Is the mean of petal length on this part here. So this is from STATA species, from Vascala species, and from the Virginica species. So this is the petal length we can have for sepals. For example, let's see what will happen. Yes, you can see we have the ones for sepals. But now a question comes, what if you want to edit your graph? For example, you want to add the title, you want to label the axis from the existing names to new ones. Where do you go? For example, when we were starting with a histogram, when you just click on histogram, even before you click OK, you can see we have a lot of tabs here or options. You will go one by one at your own time. You can add plot. So this is here. You can add the axis, the name of your y-axis and the x-axis. Then you can include title, subtitle, captions, notes, all those things. You can have legends. For example, color blue shows this, color this shows this. Yes, from there you can just click submit. There is another way you can amend those things. For example, let's start with this one here. You can amend or you can change those values direct here, or through the graphical user interface. For example, you just click on this part here, start graph editor. Yes, you can see everything has just started. For example, when you click on density here, we have the density at this point. So it means you can change the density, for example, to what name can we use to replace density? Let's say, for example, this is count. Then you just click enter. You can see we have the count there. These are the sepals, so this is another archive, and we can add title here. Let's see, when you click on this hand text, for example, you can underline and mark as grid editor. Let's see how we add this one here. I want to add it here. For example, I can see this is distribution of sepal. distribution of separate points and click let's see the size medium. Let's select medium large. Color, you can select any color that you want. Let's select, for example, green color and click apply, then say okay. You can see what you have here is the title for our graph. This is the title for our graph. So yes, that is the title for our graph. That is how we can amend or insert text in a graph. Then you can save the graph after editing. Yes, so that is it. You can just save it there. So let's see what we have next here. The other one, for example, when you click on graph and bar charts, from there you can specify the statistics that you want to plot in your graphics. For example, here we have, for the previous example, we have plotted the mean. Yes, Barata, I can see you have raised your hand. Barata, I can see you have raised your hand. Do you have anything to share with us?
Nilikuwa nauliza hapo the way you are visualizing
Yes.
this data. Naona unaenda hapo juu kwa graphics.
Yes.
Can you use the commands? The command window hapo chini.
Yes, we can use the commands.
Unaandika aje sasa?
Okay. For example, now you must have enough knowledge for the syntaxes for different visuals in STATA. So, for example, you remember last time when we were regressing, you just type regress this value and the other value, then you get the output. So the same thing applies here. For example, on the histogram, is just typing the ones histogram. So
Yes.
histogram, then you bring one value on this part. For example, histogram petal length. Imagine you are done. When you click enter, you just get the histogram for that one. So
Does it apply to all now the graphics, the graphs, like scatter plots and so on?
yes, if you have the those commands correctly, the way they are.
Let's say now you want a pie chart. Yeah?
Yes.
You just write a pie chart, then you bring one variable there.
No, the syntax changes because I want you to check here. I want, if you are, that's why when I was introducing the software, I said if you are not so familiar or you have not memorized the syntax commands, the syntax for commands, you can use the GUI, they are the same, because after executing a task using the GUI, you will get the same command that performs that particular task. So for example, on pie chart, I want us we check for pie charts. Just a minute. I want us to plot the species. Let's see. For example, you can see what we have here is the species. See there?
Yes.
So, command that is responsible for this one here is this command. So, kama ungekuwa unataka kuenda through the GUI, ungeandika only this command. So unaona it's different enough from the histogram. Here you have to specify. We are starting with the name graph pie, not pie chart. Graph pie, then comma over, then you specify the variable. Umepata hiyo rhythm?
Yeah, nimekupata. I thought like my question ilikuwa vile ulikuwa unaandika pale histogram.
Yeah.
So nilikuwa nauliza, does it apply to all the graphs now?
No.
Okay. That was my question.
Yeah. So syntax for different visuals differ. Yeah. Let's continue. Where are we?
I have a question. What is that command for scatter plot?
Command for scatter plot.
Yes.
Imagine getting that command is very simple. Scatter is here. Do you see this command?
Okay.
This is the command. Now, it's not a must you memorize these commands. You can get them directly from here. To graph. Let me disable this one here. So I want to create one. So create scatter. So these are basic scatter plots. Or for example, sepal length and petal width, for example. Then accept. Then click OK. So you can see we have the scatter plot here and its command imekuja hapa chini. Sawa. And umepata sasa. And there is another way we can apply the scatter. Let me check if that syntax is available in this one here. So scatter, I'm not sure. So now we are getting the same. So we have more than one method.
Okay, yeah.
Yeah. So ukitumia ya inbuilt itakupea this one here. So this one and these are the same. So ukikata kuanzia na 2-way, it's the same with this one here. Sawa. Yes.
Yes.
Okay.
So if You want to
Yes, Naskia. Go ahead.
legend. Can you use the command?
For which one? I have not answered your question. What? Sijas sijakupata vizuri. Please repeat your question.
Okay, nilikuwa nauliza
Uh-huh.
so venye tumeweka title kwa histogram,
Yes.
unaweza tumia commands to do the same.
Yes, you can use command to do the same. You can actually use it here. Let's repeat the same here for scatter and see what we are getting. So for this one here, this is plot number 5. See there? We have y-axis, x-axis, and title. So we can produce title and write title. For example, we can say this is histogram. Is it histogram or plot? Scatter plot. Scatter plot. For example, let's say scatter plot 1 and click OK. You can see we have scatter plot 1 here. And I want us we have a look on the command. This is a two-way scatter. I want you to compare this one and this one. Hii imeishia hapa. So from this part you can insert comma title, then you give the name of the title inside the brackets. See the same hapa. So this comma title scatter plot 1. Yeah, that is it. So
Yes.
yeah. So and by the way, every visual that you can produce in this software, there must be that part for the title. Si unapata, for example, hapo kuna title, umeona hapo, we have title there. From bar charts, we have title, these things. As because you must get them. Box plot, bado utapata kuna title. Yeah. So as well as kosa, they must be there. So yeah, they must be there. Yes, that is it. So yeah, that is for title. We can have a look on different schemes that are used to present graphics in STATA. By different schemes, I mean, for example, when you write a research paper, you can present it in MLA format, in APA, in Chicago format, those things. Now, we have schemes in STATA that are used to do what? That are used for visuals. So you can present in this format, in this format, in this format. So the easiest method to make better STATA graphs is through the use of predefined STATA graphing schemes. And some schemes, for example, we have the economist scheme. We have the SJ-S1 color and S1R color. They are all pre-installed with STATA. So let's demonstrate the one for economists, two-way scatter plot for economists. So I want to have a look on how this is. Nataka tuangalie its appearance, the appearance of the graph, and this one here. And where are they? This one for economists, this part here. So copy that one, kuja nayo hapa, just iweka. So this is two-way scatter, petal length, petal width. So scheme economist, I want you to check this one here. I think you can see the appearance changes. So this appearance is for economists, is saved for economists as far as schemes are concerned in STATA. So let's have a look on another scheme that we use. We have the Jonah scheme. We have the Jonah scheme. Let's see. Just copy this one and paste it here. This is for Jonas. I want you to have a view. This is from Jonah. This is from Jonah. So this is from Jonah. Let's view. Let's have a view on the Dant one. The Dant schema is S1 color. This is S1 color, and we can have it here. When you click enter, this is schema now, or this appearance is what is called the S1 color in graphics or in scatter, and it does not necessarily apply on scatter plots alone. It applies even on other plots. So it cut across. So let's see the fourth one, S1R color. Let's see what is happening. So these are just simple things. Yes, this is S1R color schema or scheme, the way you call it, the way you understand that name. We have the Michigan graph scheme. Let's see. Let's see what is happening here. So there's a problem here. Hii kitu yote inapaswa kukua in the same line. This is just one command, so we copy that one, replace it there, copy the second part, and replace it here. So from there, that one will work out. So this is the Michigan schema or scheme, Michigan scheme. Have you understood what you mean by schemes? Yes? I want to hear from you. I request to hear from you whether you... So those are just different formats that you can apply in your visuals, and it cuts across all the visuals actually. Yes. Let's demonstrate the one on this one here and see what is happening. For example, we have that one, and let's apply this schema here and see what will happen. So I'm applying that one here. Let's see whether it will work on this part here. Just I think this schema applies on the scatter plot, if I'm not wrong. So the other format, or the format for these schemas on different graphics may vary. So you have to be keen there. So you can just search how to apply Michigan schema on pie charts. Michigan schemas on pie charts. So from there we can have a view, we can have a look on box plotting. So in descriptive statistics, box plots is a method for graphically demonstrating the locality or spread and skewness group of numerical data. For example, this is graph box plot sepal width, petal length, and petal blah blah blah. Let's see how we can apply this in STATA. You just click on graphics and box plots. From box plots you can change either the way you want your box plot to be, so it's good when they're in a vertical format. Then from there you can select the variables that you want. Let's see, so let's select all of them and click OK and wait for the response. For example, what do we mean by this type of box plot? It means that sepal length is this color here, so sepal length is this color here. So it means all values of sepal length are concentrated between like 4.5 here and 6 it's 6 or 8, between 4.5 and 8. So there, and we expect actually its mean to be somewhere here. This is the mean, about 5.8, around there. So yes. The other one is on sepal width. This one here, this one is for sepal width, that is its distribution, and the other one is petal length. You can see its color here, So it means that for petal length, the data points are so much spread. You can imagine the lowest here is 0.31. I think this is around 1, and the highest is almost 7 here. It's almost 7. So we can see that petal length points are not so much concentrated on one point according to these box plots. We have the other one for petal width, this part here. Yes, that is it. So from here you can just you may either descend it to do ABCD in your graph. You can rename this graph by this point here and just type this, for example, box plot 1. Yeah, that is box plot 1. Renaming does not mean that's the title. So you've just renamed it. You can insert your text to say this is your box plot for different words, for different measures. Box plot for different measures, that makes our title, right? What else do we have, or what else can we include? So let's say, for example, here we have the density. Density, you can format, you can do justification, either let's see, let it be default. So yeah, so vitu kama hizi you can do a lot of things here, especially you can have if you realize that you made a mistake, for example, here you may not be able to delete this part directly, but you can have rid of it through these parts, the undo. That's it. Let's check on the advanced offset format box plot text. Okay, so you understand when is it necessary to use box plots, and after you have just produced your box plot, you just get the command responsible for that. So you can get command that is responsible for that. So there is graph box sepal length, sepal width, petal length, petal width. So this is wrong. It means to may overwrite our graph. So iko sawa, it's okay. Yeah, that is it. Let's see. There is that part. So on this part you can have we have done, you can even produce the line plot instead of having a box plot or the scatter plot. You have them. Let's see. Okay, let's say for example we want to plot 5 to have not scatter but to have a line, and let's see, that is one, and the other one is the sepal width. That is sepal length and sepal width. So we want a line instead of scatter plots. So you can just have it. So now there you can have those points. You can have those points. Or what else can we have here? You know the scatter matrix, these are regression diagnostic plots. So these are for time series. Do you remember when we were doing line plot for time series? So for you to do anything here, you must have specified your variables to be in time series format. Your data must be in time series format. So scatter plot matrix. What do you think has not been covered on this part? Or who has any burning issue? Okay, let's suppose we want to have a dot plot. Let's see. The dot plot. Nani yake inakuja? Inakataa. I don't know why. The one coming is for this part here. You can have the smoothing and densities, for example, but now for you to run some tests here or to run some visuals here, you must specify or there are some plots that are associated with specific areas of study. So that's why we cannot exhaust all of these ones. But we have done just the simple ones. Are we okay? Are we together? Yes. So some tests are actually not associated with, some tests are not associated with some standard, while others are associated with some standard, like the one we have discussed on the line plot for TSS data. Yeah, that is it. So yeah, and that makes the end of visuals that we were to cover today. Friend, do you have any question? Any question?
Yes.
Yes.
So, can you move those plots to a Word document?
A very good question. A very good question. Let's demonstrate that. because actually the main important of using this STATA is to help you do what? Analyze data and write a report in Word format. Let's open our Word document, and then we can suppose this is okay. What happens when you right click, when you just right click and copy paste? So you right click, you copy, then you paste to your want. Friend, are you okay now?
Yes.
Yeah. So that makes the end of today's session.